Hello and welcome back. My name is Andy and here we are learning Python. We have used in the past many features of Python that are built in, but of course the amount of stuff you can put into a language like Python is necessarily limited. You don't want to blow up your language too much because if you make the program too big, it takes much longer to install, it takes much longer to run and so on. So with Python, they try to keep the core of the language relatively small and the functions that are offered only the most important ones. And then they added a mechanism how you can include other external modules that extend the functionality of the language with new functions. So Python has lots of built-in functions like print and int and input, but for more specialized cases, you just include another module. A module is a file, a separate file containing Python definitions and statements like a toolkit of pre-written code, and many of these come together with Python bundled, so most of the modules you will need are already included in Python, but some are also external. You install them separately and then you can use their functions. And to use a module, you must first import it at the top of your script, and this makes it available in your script. And later, when you want to use a function from this module, you do it like this: module name dot function name. It's just like calling a function from an object, like we said before, right? When you have the string object and you call the upper function to turn it to uppercase, the method. So in this case, it's a similar syntax, right? Where you use the module name dot function name. And here you see an example of that. We import the math module, which contains advanced mathematical functions. Of course, you can do basic arithmetics in Python without this, but if you want something more advanced like square roots, then you can do this, and you say the result is math square root. This is what SQRT means, and then in brackets the number 81, and you print the result. Math has lots of other functions for mathematics, for example, rounding functions, or here the function ceil, which means ceiling, which is rounding up a number, taking the next higher number after a number that has a decimal point, the next higher round number integer. Here we want to calculate how many pages we need for a particular number of words. And so we say we have a total words, and then we have the words per page. And so we want to divide them, total words divided by words per page. But you don't want to have a result that says you need 235.756 pages. This is a little silly because we don't have any decimal fractions of pages. So what we do is to calculate the ceiling of that, the next integer after the number. And so this is what happens here. Let me start it and show you how it works. Okay, and this is just a demonstration again of the math module. You see import math up there, and then you see how we call the function. We say math.ceil, which is the ceiling function. So the math module generally provides access to common mathematical functions and constants. We already talked about SQRT, the square root, the ceiling. There is also, of course, the opposite of the ceiling is the floor. It rounds down. And then there are also some useful constants in there. Pi, as the Americans call it, math.p, pi is a constant that holds the value of p 3.1415926.535 and so on. But there are many, many more. So there are often hundreds of functions in one module. You have to go and look at the module documentation, and then you will see all these functions. I show you briefly here the documentation for the math module. You see there are many, many functions that you can use and that make your life much easier. Another very important module that you might want to use in your programs is random, because we often need random numbers. You want to, for example, have some dice. You want to make some simulation that requires some random number, or you want to make a card game. You need some random numbers. or you want to just pick a random element out of some list. And this is what the random module does. So you import random, and then you have various functions that allow you to choose, for example, one random element out of a list. And this is what you see here. So we import random, we have a number of figures, and then we want to choose randomly one person. So we say chosen figure is random.choice. So the function we want to call is choice, and we pass it a list, and then this will randomly choose one of the elements of the list and return it, what you see in the next line. And the next thing we do in the same program here is a dice roll. Roll is random rand int. So rand int again is a function of the random module that gives us a random integer. And you give it two numbers, the smallest and the biggest. So the limits, right, including these limits. And so we get a number between 1 and 6, including 1 and 6. And then we print you rolled a roll, and roll is of course the result of rand int 1, 6. So let's execute this, see how it works. No surprises there. The next very useful module is date time. This allows you to calculate dates, and dates are hugely important, of course, in everyday life. You want to know what weekday is today, for example. You want to know how many days are between two dates, which can be tricky because, months have different numbers of days, especially if there's a February involved. So here are some things the date time module can do. Import datetime, and then you say now equals datetime dot now. And so this now gives you the current date and time. You can create date objects for specific dates that you want to work with. For example, historical dates. I can say date of invasion is the datum dot date, and then I say 1944 6 6, this is the 6th of June, or end of war in Europe is datum date 1945 5 8. So this is year, month, day always. And now I create an object that is a date object. It's not an integer, it's not a string, it's a specific date object, and it has its own methods, its own functions to deal with dates. So now I can say the duration is the end of war in Europe minus the day of invasion. So in this case, I can subtract 2 days from each other, and Python knows what to do because these date objects have a method that deals with subtraction, with subtracting 1 day from the other. And so I get a number of days as a result between these two dates. So let me do it here, and you can see what happens. Okay, so this is incredibly convenient if you want to talk about durations. So this provides classes for working with dates, times, time intervals, and is crucial, of course, for historical research. Datetime now returns a datetime object with the current local date and time, and then you also have other methods that will convert it to other time zones. You can create a new date by using date with year, month, and day like we did, and you also have this function strf time. The names are not always easy to pronounce, means string format time. So you can make a string formatting of a particular date, and you give it the format you want. And this is a very powerful function, very flexible, because in this formatting string, you can say how you want it formatted. So in this case, for example, I want it formatted with dashes, and then I can do this, right? And I can format it with 2 digits, with 1 digit, in any sequence I want to have the month and the date, and so on. A module that's perhaps less interesting in general for the beginner, but sometimes may be very important, is OS. OS is a module that directly interacts with your operating system. This can be more advanced functions, but it can also be something like reading a file. If you want to read a file or to save a file, then, or to save data in a file, then you need the OS module. You also have to be careful when you're using cloud services like Google Colab. The files you save there are not the same as a local file. For example, Google Colab might disappear them after a while, depending on your contract, when your session is over. So you have to make sure that you save the data somewhere else. You can save them on your Google Drive or something, but you have to be a little careful about cloud services and the OS module. And not all functions may work, right, in Google Colab, because obviously Google doesn't want you to mess with their operating system. So these work best and in the way you expect it on your local machine rather than in this cloud environment, although in many cases it does work. So you can save files on Google Colab, you just need to be careful where you save them and how long they stay there. Okay, here you see an example. We import OS and then we open a file. We give a file name that should be opened. And if we can open the file, we get a success message, and otherwise we get an error message. And at the end, it tells us where this script is running. So I will just execute it so that you see. Of course, it will not find anything because I don't have this file, but you can see the messages it gives us. Okay, that's it. Thank you, and see you next time.